Chapter 8, Cost Accounting Examples. Chapter 8 talks about cost estimates and how we make cost estimates using historical information. When we make cost estimates, we're looking at mixed costs and how do we tell which component of a cost is the fixed component and which is the variable component. You'll remember our mixed cost formula is the formula of a line, y equals mx plus b, or total costs equal variable costs times the units plus total fixed costs. So the information that we are giving is total costs and the number of whatever our variable driver is. So in this, we have two potential drivers of cost. We have the square feet of a house and the number of external openings of a house. And we can use either one to develop a cost equation. So we're going to use the high-low cost estimation technique. We're going to start with square feet as the independent variable. So we're going to use the high-low to determine our variable and fixed cost portion of the total cost. So we want to look for our high amount and our low amount. So we're looking at the number of square feet. Our high amount is 4,600 square feet, and our low amount is 2,500 square feet. When we're using the high-low method, it is the change in cost divided by the change in the activity base. So we're going to look at the change in total cost divided by our change in square feet. It is the cost associated with those high and low components. So we have our high costs at 4,600 minus our low costs divided by our high base minus our low base. And the result is 90 cents. Our variable cost is 90 cents per square foot. We can use that information and one of the points of our information to determine what our total fixed cost is. So let's use our high point, 4,600 square feet and 4,700 in total cost. So we would have $4,700 equals 90 cents per square foot times 4,600 square feet plus B, which is our total fixed cost that we're trying to solve for. So 90 cents times 4,600 square feet is $4,140. We need to get that on the same side of the equation, so we subtract 4,140 from each line, or 4,140 from 4,700. So 4,700 minus 4,140 equals our total fixed cost. Our total fixed costs in this case are $560. So our equation is total costs equal 90 cents times our base, activity base, plus $560. We can use that to make cost estimates based on the square footage of house, because our base is square feet. So it says, determine the cost of painting a 3,300 square foot house and a 2,400 square foot house. So if we have our 3,000 square foot house and a 2,400 square foot house, and we are going to make estimates for both of those. So 3,000 times 0.9 plus 560 gives us total cost of $3,260. 2,400 times 0.9 plus fixed costs of 560 equals $2,720. Part 2 of this question says repeat requirement 1, but use number of external openings as the independent variable. So now we need to see what are our high external openings and what are the low external openings. You see here that high is the 19 and low is 10. We use the total cost associated with each of those. So we have our high cost minus the low cost divided by our high activity base minus our low activity base. This gives us a cost of $162 per external opening. We can then use that information to determine the fixed cost part of this equation. So at $4,700, we have 19 openings. $4,700 equals 19 external openings times $162 per opening plus total fixed costs. So we need to take $4,700 minus $3,078 to get our total fixed costs. Of $1,622. So if instead we use external openings, our cost equation is total estimated costs equal $1.62 times external openings plus $1,622 in total fixed costs. We can then calculate the estimated cost of a house with 14 external openings and 8 external openings. $14 times $162 plus $1,622 in fixed costs for a total cost $3,890, or $8 times $162 plus $1,622 in total cost. The company can use either method for creating a cost equation that they can use to give future estimates on projects. Part 3 then says, plot the cost data against square feet and against openings to determine which variable is a better cost driver. So we're going to graph this information. First, we'll select external openings and costs. We will say insert. We want a scatter plot. This gives us a graph that shows if our cost information is linear or not. Our cost information is mostly linear with external openings as the cost driver. We do have 2 points, so we have point 13, so that's 13 openings, and this point over here at 10 openings that are somewhat outliers of our general line. So now we want to look at square feet versus costs. So we select that information and we insert our scatter plot. And we can move those side by side and look at them. This information is more linear. We can draw a line at what our costs are with the square footage. So looking at these two graphs, I would say that square footage has the better relationship between the choice of two cost drivers if I was only going to select one of them. Next, we're going to look at that exact same information, but we're going to do a regression analysis. And we're going to use both of the options for our regression analysis. We'll look at each of them individually, and then we'll do them both together. So for regression analysis, we need to have the data analysis pack for Excel installed. And how you install that, on a PC, you go to File, Options, Add-ins, the Analysis Tool Pack, and then Go. For an Apple computer, it is called Tools, and then Options and Analysis Tool Pack. So we'll go to our Data tab and click on Data Analysis. Brings up this box, and we are going to say we want a regression analysis. So we're going to select Y is our cost, and X is the number of openings. We can select that it ends up in a new worksheet, or we can select an output range and drop it into this worksheet. This is using external openings. What we see here is this information about the number of observations. We had 12 observations, what our multiple regression and R squared are, the standard deviation, different information. And what we're looking at here is our intercept and our X variable. So for openings, this gives us a cost equation of $204 times each opening plus total cost of $671 equals total costs. So we'll notice that that was slightly different than the high-low comparison. The regression is considered more accurate. Remember, we had those two outliers that could cause some issues with our calculations in the high-low. We can also look at that for the square feet opening. So we'll have the same Y range of total costs, but now we want square feet to be our X. Our output range, we're going to put it over here so we can look at them side by side. Now we have a regression analysis for 6 feet. We see we're over square feet. We see we're a lot closer on the high-low with square feet. Here, we get a variable of 89 cents versus the 90 cents that we had from the high-low. And our fixed costs then are $742 to give us our total cost. Or we can create a multiple equation where we look at both of them together. So a multiple regression. We have total cost is still our Y range. We're going to look at square feet and openings together. We're going to select for our output range. Let's put that below here. So this is with both of them together. What we have then is fixed cost of $641.76. Variable 1 for square feet is 71 cents, and variable 2 for number of openings is $48.35. So our cost equation then would be total cost equals 70 cents times square feet plus $48.35 times external openings plus total fixed costs of $641.76. Regression analysis gives us the most accurate cost equations for mixed cost versus the high-low method. The last example we're going to look at is where we have seasonality factors for our regression analysis. So as we can see here, we have 3 years of information, and we're trying to see how supplies expense is related to either total sales in either units or dollars, and how that drives our supplies expense. But as you can see, in December, we have much higher amounts. And so first we'll run a regression analysis. We're going to run it based on sales units and one based on sales dollars to try to determine which one is a better indicator. So in our regression analysis, supplies expense is our Y. And then we need to choose whether we're looking at units or sales dollars. So let's look at units first. We're going to select an output range below our data. So we have our information about the 3 years. We're given a variable cost of $1.92 and a total fixed cost of $211. We want to look at our p-value, standard error, look at our R values. This is for sales units. Then we'll look at a regression analysis with sales dollars as our result. As our X, and see if that is a better indicator than sales units. Okay, we actually have that it is not a stronger indicator than sales units. As you see, our R values are much lower, and our standard error is higher. Okay, now we're going to account for seasonality. When we have seasonality in a month where our changes are significant, as we can see here. In December, our sales are vastly different than sales during the rest of the year. When we have seasonality in a regression analysis, we are going to create a dummy variable. So we put in zeros and then a 1 for the season that we have. We could also put, if November was much higher, we would put a 1 in November to show that November and December are seasonal areas. Now we're going to rerun our regression analysis. We're going to look at the supplies expense as our Y. And for X input, we're going to run both the sales units and the seasonality together. And we're going to then output right underneath our table. Now we look at this has helped our equation significantly. We've accounted for that seasonality with the second variable, and that gives us our different cost equation.